Today, I'm going to be talking about finding the sides of right triangles. The Greek mathematician Pythagoras came up with the Pythagorean Theorem as a way to find the length of the hypotenuse of right triangles, and right triangles only. The hypotenuse of a right triangle is its longest side, always opposite the 90-degree angle. The theorem states that a squared plus b squared equals c squared, where a is the length of one of the legs of the right triangle, b represents the length of the other leg of the triangle, and c represents the length of the hypotenuse. Say we have a right triangle with legs of 3 and 4 units respectively. To find the hypotenuse, we must use the theorem and plug in 3 and 4 as a and b to get 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. So you square root both sides to get 5 equals c. Hence, the hypotenuse of a right triangle with legs of 3 and 4 units respectively is 5 units. Now say we have a right triangle with a hypotenuse of 10 and a leg of 6 units. To find the length of the other leg, we plug in 6 as a and 10 as c to get 6 squared plus b squared equals 10 squared. 36 plus b squared equals 100. B squared equals 64. Hence, b equals 8. Our final example regards the converse of the Pythagorean theorem, which states that if the sum of the squares of the two smaller sides of a triangle is equal to the square of the third side, the triangle is a right triangle. Now, we have a triangle with sides of 4, 5, and 6 units respectively. Because 6 is the greatest side, it is supposed to be the hypotenuse. 4 and 5 are supposed to be the legs, represented by a and b. To determine whether or not the triangle is a right triangle, we must plug our lengths into the Pythagorean theorem and evaluate whether or not the resulting equation is correct. 4 squared plus 5 squared equals 16. Plus 25. But that adds up to 41, not 36. So, the triangle in question is not a right triangle. You'll notice that for the first two examples, the hypotenuse and leg that we found were both whole numbers. This is actually a rarity, and sets of 3 whole numbers and their multiples that satisfy the Pythagorean theorems are called Pythagorean triples. For example, 3, 4, 5 is a Pythagorean triple. 6, 8, 10, a multiple of the set, is also a Pythagorean triple. I also have listed more. 5, 12, 13, 8, 5, 17, 7, 24, 25, 20, 21, 29, all of their multiples, and infinite more. There are two types of special right triangles, denoted by their angle measurements. The 45, 45, 90 right triangle is an isosceles right triangle with two 45-degree angles and a 90-degree angle. To find the hypotenuse for these special right triangles, all you have to do is multiply the leg length by the square root of 2. For example, if we have a 45, 45, 90 triangle and the leg is 4 units, the hypotenuse must be 4 times the square root of 2 units. The other special right triangle is the 30, 60, 90 triangle. A 30, 60, 90 triangle's hypotenuse is twice the length of the smaller leg. The larger leg is the smaller leg times the square root of 3. For example, if we have a 30, 60, 90 triangle whose smaller leg is 5 units, the larger leg is 5 times the square root of 3 units, and the hypotenuse is 10 units. An interesting fact about the 30, 60, 90 triangle is that when it is reflected across its longer leg, an equilateral triangle is formed. Now that you know what it is, you might be wondering, how do I know that it works? Well, I'm going to show you a proof I made for the Pythagorean Theorem to clear any doubt from your mind. So I'm using GeoGebra. It's an online free tool for graphing and drawing polygons, and it's really useful. So first, we draw a right triangle with arbitrary side lengths. I'm going to choose 3 and 4 for simplicity's sake. So we draw our first polygon, our first right triangle. Now, we're going to draw another right triangle with the same dimensions, but rotated above the first one so that they share a point. So what this is really doing is we're going to draw a triangle that is rotated 90 degrees clockwise, like so that it shares point A. Now we're going to do the same thing over here, yet again rotated. So now we have these 4 triangles, and you might notice that in the center there's a square that is formed. We are trying to find the hypotenuse of one of these right triangles. As you can see, there's a square in the center. The square's side length is the hypotenuse of each right triangle, so we're going to find the area of the square and square root it to get our final answer. The way we will find the area of the square is by finding the area of the larger square formed by the triangles and subtracting the area of the triangles. Each side of the larger square is a plus b, which is better shown if, say that a was 4, so this would be a, this would be b, this would be a, this would be b, and, etc. for the other 2 sides. Hence, the area of the larger square, that is to say dBHF in this case, would be a plus b squared. Now, this is simple algebra that a plus b squared is equal to a squared plus 2ab plus b squared. Hence, the area of this larger square is a squared plus 2ab plus b squared square units. So now we need to subtract the area of each of these 4 right triangles so that we can find the area of this smaller square. So each of these triangles has an area of AB divided by 2. 8b divided by 2. So since there are 4 of them, we multiply that by 4 to get 2ab. And now we just have to subtract a squared plus 2ab plus b squared minus 2ab equals a squared plus b squared. Pretty simple. So now we have the area of this square. So now we simply have to square root it. So c is equal to, c being of course the side length of the smaller square, or the hypotenuse of each of these or any of these right triangles. C is going to be equal to the square root of a squared plus b squared. and this is the Pythagorean Theorem. Hence, it must be true. The Pythagorean Theorem is overall a very useful tool to find the side lengths of right triangles and determine whether or not a triangle has a right angle. Thanks for watching. Apologies for the delay of posting this video. I've been very busy with school. If you have any concepts that you want me to explain, please leave a comment and I'll be sure to explain them in a subsequent video. Don't forget to like, subscribe, and share. I'll see you next week, hopefully.